So I'm here in Santiago on another beautiful day at the University de Chile in Santiago, which is the oldest university in all of Chile. And I'm standing here with a man who did a brilliant job organizing a conference in Puerto Varas, Chile, about an hour and a half flight south of Chile on the edge of Patagonia. Weather there was a bit cloudy, but the talks were great, and the title of that conference was Cosmic Streams in the Era of the Rubin Observatory. So Francisco Forster is an astrophysicist here, and he was both the scientific and local organizer of the conference. Francisco, tell us basically the gist of the reason you had this conference, and it attracted leaders in scientific data management and astronomy from all over the world. And also, you yourself had specialized in type 1a supernova as one of your research topics. So tell us the rationale for the conference that just took place and the 2 or 3 takeaways from the conference.
Yes. So the conference was organized recently in Puerto Varas, as you said. There were about 80 participants, and the idea of the conference was basically we're 1 or 2 years away from the start of Rubin, so we really need to start talking to the community that is running brokers, survey telescopes, follow-up telescopes. They're doing science with these new big volumes of data to agree on what we need, what is missing, what is already achieved, and how we can share resources.
And what we did, and for the reader, Rubin, I did a story. I visited the telescope site a couple of years ago before COVID, and it's posted on Forbes as well if you want to look that up. But the Rubin Observatory is going to revolutionize what is known as transient astronomy. And it goes online, I believe, starts taking data in the commissioning phase at least, I believe in the middle of next year. Is that correct?
Yes, that's the current plan.
Yeah. Okay, and it's a very wide field telescope. And over the course of its lifetime, it will image every part of the sky.
In the south. Yeah.
In the southern hemisphere at least, 800 times. Is that right?
Yes, that's the typical number.
Okay, so but the interesting thing is, you told me just now in our interview that it's going to create at least 10 to 14 million alerts per night.
That's true. So every time the observatory will visit a new part of the sky, typically will trigger about 10,000 alerts. So these are packets of data that will be streamed.
You mean 10 million alerts?
For every observation, it's about 10,000, but there are 1,000 observations typically per night, so that's 10 million.
10 million, okay.
And between 10 and 40 million per night. But we need to react to this in real time in order to notify the community, the users that are interested in different science cases, to help them identify their science among this huge stream of data.
So it's a data management problem more so than a scientific problem.
Yes, we're intermediaries, so it's a data management problem, but also machine learning, let's say, because we need to classify things very fast. We need to help the community do their science. So one of the biggest, most important takeaways from the conference to me was the importance of detecting anomalies, outliers among this stream of data. So this is a very hard problem.
Now, how would you define an astronomical anomaly?
So it's either an object that has some behavior in time that is not known, so it's a new class, let's say, of astrophysical event, or it could be a known class of event that has not been observed, and so it's observed for the first time. It was expected to be there and will be suddenly found, or it could be a known class that has been observed but presents some anomalous behavior in time at some point in its life.
And a transient event, just give us a brief parenthetical definition.
Transients are events that are usually not there in the sky, and then at some point they appear, they live for weeks, years, depends, and then they disappear. So you have only one opportunity to look at them before they vanish.
And they can be everything from passing asteroid to a comet.
Could be asteroid, supernova, extragalactic explosions. But LSST will not only do transient, they will also detect persistent objects, so pulsating stars, active galactic nuclei, things that change in time. So it's time domain science, really the aspect that we were interested in this conference.
And if there was one overriding factor, you had on Friday at the end of the conference, you guys kind of had a roundtable, casual discussion.
Yeah, well,
what was there one factor that kept coming up?
Well, it's the importance of organizing ourselves to detect outliers, to develop new
Outliers,
anomalies, but also that there is a lot of science coming out of these streams of data with the help of brokers that was not possible to do before. So we
the brokers are they're not Wall Street brokers,
No.
but they're brokers which are nonprofit groups that have developed ways to filter the data for individual groups or astronomers at either observatories or institutions.
Yeah, so the brokers are the only groups that will receive this stream of data because it's so large that you cannot just give it to all the community. Brokers will receive it, and we will help the community do their science with this stream.
Right.
Lastly, I mean, we are learning from each other on the brokers. We are 7 brokers today, and we are in a kind of Cambrian explosion. Everyone is exploring different directions. We are converging in some ways, and we are discovering new ways of doing science.
But it's a collegial effort. It's not meant to be competitive, but
there is some degree of competition, yes, which is healthy, I think.
Right.
But it's a lot of collaboration as well. Yeah.
Okay. Well, when do you expect to actually? When do you expect the observatory to be in full routine science operation? Do you have any idea?
I think it's 2025 probably.
2025.
Yeah.
Okay.
And then the alert stream will take some time because you first need to observe all the sky to be the templates that will be the reference point for all the changes that happen within the stream.
Okay.
So it will take some time, maybe 2026, to have the alert stream running. 2027, I don't know.
But anyway, well, thank you so much, Francisco, for a
Thank you.
brilliant conference. I enjoyed being there. It was a learning experience for me, and we look forward to hearing more from you when the Rubin Observatory and the LSST are actually in routine science operation.
Yeah, we're also very excited, and thank you for your interest, and and thanks for coming. Yeah.
Thank you.